Okay, everybody, today's goals are related to osmolarity. And I was thinking about this because I just got discharged from an outpatient procedure where I needed some saline solution. And right there on the bag, it told me the osmolarity of this solution. And that I really like this concept of osmolarity because it tells us like kind of a more functional definition of concentration, because what osmolarity really tells us is the kind of concentrations of multiple components in solution and how they relate to like their electrical components and what's actually in solution, what's actually doing the dissolving. So just as a quick reminder here, so we can see our goals there. We're going to use the osmolarity formula to calculate and identify the value of I for ionic and covalent compounds. So this is just a quick reminder. So going back to ionic compounds, just as a reminder, I know you guys remember this, that this is going to be, these are going to have metals plus non-metals in the formulas. Or it's going to have polyatomic ions, or pies. If you see those, you know it's ionic. And here's the important reminder. So the ionic compounds separate into their ions in solution. And what that means is we have sodium chloride. Sodium's a metal, chloride's a nonmetal. In solution, we're going to end up with sodium ions. It's +1 charge because it's in group 1. Chloride ion. In solution, it's going to separate. Covalent compounds don't do that. Oops. If I don't put 4 bonds on carbon, my organic chemistry professor is going to scream at me. It's like methane. Methane is still going to stay methane. CH4, it's still going to be CH4 in solution. And so that's really the difference between ionic and covalent compounds. So covalent compounds, that's going to be 2 nonmetals. And these aren't going to separate into solution. They're going to stay put. Their bonds aren't going to break in solution because they don't have that full distribution of charge. So that's really what's going on the chemistry level. And that's really important for the formula here. So I love osmolarity because it tells us these differences and it takes that into account in the formula. So what's the formula? Get to it, Dr. Poe. Got you. I got you. Okay, so we've got osmolarity. The part that takes this into consideration, we call that I. It's a lowercase I. I kind of write it cursive-y. And then we're going to multiply that by the concentration in molarity. And if you have more than one component in there, you're going to do this for each component. So this would be like component 1, component 2, if there's 3 components. Because like a lot of times in glucose solutions, you're going to have a little bit of salt in there. So, just however many components there are, you would consider each one individually. But for right now, we're just going to simplify it and just take this one step at a time. Okay, so we've got our osmolarity formula. I times M. What does this mean? This I, that's the number of ions or the number of parts in solution. So, for our sodium chloride example, we have 1 part here and we have 1 part here. 1 + 1 = 2. So what's the easiest way to do this? You just add up all the subscripts of your ionic compounds and that gives you your value for I. So NaCl, the I value is going to be 2. For our covalent compound, any covalent compound, because they stay put in solution, the I is going to be 1. There's one thing in solution. It didn't separate into individual components. It's one component. So that's really like those parts or components or ions in solution. That's this idea of I. The M that we see here, this is the concentration in molarity of that component only. So if you got a solution of glucose and sodium chloride, you consider each part individually with its I and its concentration. You add it all up and you get the osmolarity of the whole solution, which is something that molarity itself can't really tell you. So that's why I really like osmolarity. It brings it all together into one nice formula. All of our examples today, we're just going to do one component, but just know you could add it all together. You could do that. Okay, so there's our component, and that's this idea of I. So remember, important thing to remember, our important caveat for covalent compounds, which are two nonmetals, I equals 1 always. They don't separate into ions, so their I value is always going to be 1. You're probably not going to be asked that on any exams, but you never know. You never know. Okay, so now let's do a practice question. Womp. Okay, so here's our practice question. Which of the following solutions, I'm going to abbreviate solutions SOLNS, that's solutions, has the greatest osmolarity? And let's make this multiple choice. Has the greatest, meaning the biggest, osmolarity. Because they're all pretty great. So what about 1 molar of NaCl, B, 2 molar of glucose, and we'll give the formula C6H12O6, C, 0.5 molar of calcium chloride, or D, 0.5 molar of aluminum oxide. Okay, so go ahead and pause your video if you want to try to figure this out on your own, and we're just going to jump right in and solve it. Okay, so to solve each one of these, what we're going to do is we're going to use our osmolarity formula, and our osmolarity formula is that value of I times the concentration in molarity. So we can see in each one of these we have the molarity given, and it's a little bit different for each. So how are we going to figure out that value for I? For this first one, we're going to look at this formula, and we're going to add up all the subscripts. 1 plus 1, our I is going to be 2 because this is an ionic compound. Because we've got our metal and our nonmetal. So we're going to take up our subscripts, and that's our value for I. So for our first one, taking I times M, our I value was 2 for NaCl, because there's going to separate into our 2 separate ions, and our M value was capital M, 1 molar, and so 2 times 1 is going to be 2, and our units here are going to be osmoles per liter. Okay, and you can abbreviate that OSM per liter, but that's our units that we're working with today. Okay, next step. Okay, 2 molar of glucose. So looking at glucose, we know that this is covalent. So our I value is going to be 1 because covalent compounds don't separate in solution. So that makes it really easy. When we do our I times our M, we are going to get our value of 1 for our I, 2 molarity for our M. So we're going to end up with 2, and I'm going to use the abbreviation, osmoles per liter. Osmoles per liter. Next one. Hopefully you guys are getting pretty good at this. We've got our molarity there. We need our value for I. We're going to add up our subscripts. 1 calcium, 2 chlorines. Our I value is 3. So we're going to take I times M. That's going to be 3 times 0.5 M. And that's going to give us 1.5 osmoles per liter. Last one here. We got to figure out our I value. This is again ionic. We've got 2 plus 3. Our I value is going to be 5 here. How nice. And so our I times M is going to give us 5 times 0.5 M. And that's going to give us 2.5 osmoles per liter. Okay, so our best answer here, which of the following solutions has the greatest, meaning the largest osmolarity? Answer is going to be D. So I hope you found this helpful, and best of luck on your exams.